Hi everyone, and welcome back to the solutions for the June 2024 CSEC Add Math Paper 2, and we're on Section 3 Introductory Calculus, question number 4. So I just want to say that this part of the question has actually never come before in CSEC Add Math, and is something that is on the syllabus. It is a specific objective, that is where students are required to use the definition of the derivative as a limit to find dy dx, meaning they need to know how to differentiate from first principles, which is something that was only done in Form 6 math before, but CSEC now has actually brought it as a question in CSEC Add Math. So students are required to know this process, and to explain this, I don't want to go too much into depth into the explanation because it would make the video extra long. But if you just go on YouTube and type in differentiation from first principles, there are many videos explaining the process. So first, you have to know what the concept of a limit is, and secondly, f-x, which is the notation used here, actually means dy dx. So f-x, when you're using differentiation from first principles, it is the limit as h tends to 0, and of course the YouTube videos on differentiation from first principles will explain all of this. Unfortunately that I can't explain it here, but I'll just show you how you calculate the limit. So the limit as h tends to 0 of f of x plus h minus f of x over h. So basically, f of let me just rewrite this. F of x plus h. So we substitute x plus h into the function for f of x. So inside the brackets, we're going to have x plus h, and of course we're squaring that, and then we're subtracting 3. So it's basically just substituting x plus h as x in the function. Then we subtract f of x, and I'm going to put it in brackets, and we divide that by h. So let's simplify the numerator. So x plus h squared, I'm going to use the identity a plus b squared, right? So that will be x squared plus 2xh plus h squared. And expanding the second pair of brackets, we have minus x squared. Minus by minus will give plus 3. Okay, I should have wrote a little smaller here. So simplifying the numerator, x squared cancels, 3's cancel, and we end up with 2xh plus h squared over h. So of course, if you're dividing both terms by h, which you can, because if we factorize h from the numerator, it will cancel with this h in the denominator. So of course, we end up with 2xh divided by h will be 2x, and h squared divided by h will just be h. Now, the limit of this expression as h tends to 0, meaning as h tends to 0, if I substitute 0 here, then I'll just end up with 2x. So therefore, the limit is just 2x. In other words, to cut a long story short, f-x represents dy dx. So if I differentiate f of x, I should get 2x, which is the whole moral of the story. And we do know if we differentiate x squared, we do get 2x. Okay, so this whole thing is worth 4 marks. So the hence part 2, hence determine the value of f double dash of 5, right, which means the second derivative. And this is worth 2 marks. So if we know the first derivative is 2x, then if we differentiate again, second derivative, meaning if we differentiate 2x, so differential of 2x would just be 2. So therefore, it doesn't matter the value of x, the second derivative will always be 2. So the second derivative of 5 will still be 2.